This is not sedimentary rock.
You can learn a lot about different types of rock by just going to the beach.
This is sedimentary rock.
You can tell it's sedimentary rock because of these layers. This experiment helps us illustrate how sedimentary rock forms. Layers of broken up rock and other organic or living material is deposited over time, forming these distinct layers. They then dry out and cement. This process forms distinct sediments of rock, which is how it gets its name. These layers then get compressed over time due to the pressure of the earth and the rocks above them.
One of the properties of sedimentary rock is that it's very brittle.
Just kidding, one of the properties of sedimentary rock is very light.
So how do we get the smaller bits of rock that's needed to make sedimentary rock? To find out, we can do a simple experiment by placing some water between two rocks and placing them in a freezer.
So what happens during certain types of erosion is that you can get water that goes in through the gaps in rocks, and when the temperature changes, as the water freezes, it expands, and you'll see in the experiment what happens as that water expands inside these cracks.
Take a look. The rocks have been pushed apart because the frozen water has expanded. This is what we call mechanical weathering. The water's pushed apart two rocks into two distinct chunks. Now we've got two other types of weathering, chemical weathering and another type of weathering that you can see quite clearly on the cliff edge.
This is biological weathering.
This is also sedimentary. Sedimentary, baby.
This is also sedimentary rock.
This is igneous rock.
Igneous rock is all about lava and magma. And Seb, what are you doing? Hang on, Seb, wait, no, Seb, no! In the game Minecraft, you can cool down lava using a bucket of water to form obsidian. Now, did you know that you can also use lava to create cobblestone? If you cool down flowing lava with water, it will form cobblestone. Now, this is true to life. These are both types of what we call igneous rock, which is a rock formed when lava has cooled down to its solid state, which is what we call igneous rock. You can recognise igneous rock from its crystalline structure and often glassy appearance, like you can see here. This experiment that we're going to do next is pretty sweet. The first thing I'm going to do is place one plate in the freezer and one plate in the oven. I'm then going to need to have a substitute for lava, and I'm going to use sugar for this. So the first thing I'm going to do is heat up the sugar so hot that it melts into liquid sugar. So this represents our lava or magma, because all lava or magma is melted rock. Now when a volcano erupts, what's going to happen is that liquid rock is going to go out to the land and it's going to solidify, and that's what our two plates are for. The hot one is going to cool very, very slowly. However, the cold one is going to cause a rapid freezing. This is going to form two types of igneous rock, one that's cooled quickly and one that's cooled slowly. So let's have a look at our results. What did the sugar do? The cold plate froze it fast, resulting in lots of small little crystals. The hot one froze slower. So we've got these massive crystals, which is exactly what you'd see in igneous rock. This experiment showed us the difference between two types of igneous rock. The first is extrusive igneous rock, which freezes fast. Two examples of this is obsidian as well as basalt, and you can see that they haven't got any crystals. A second type of igneous rock is intrusive igneous rock. Now these types of igneous rock freeze slowly, so they get giant crystals. And if you look at this picture of diorite as well as the granite, you can see just how large those crystals are.
Let us know in the comments, what sort of rock do you think this is? Yeah! And this is metamorphic rock. Whoa!
Metamorphic rock is rock that started as one type of rock, such as sedimentary, igneous, or another type of metamorphic rock, and over time it's been changed. Now in our first experiment we're going to see how. Now what I'm going to start off doing is simulating the creation of sedimentary rock using 2 bits of Play-Doh. So I'm going to break up our 2 bits of Play-Doh and form layers. Now these layers are going to get compacted over time. However, in real life what would happen is those layers would get pushed deep down underground and they'd be exposed to a lot of pressure and an incredibly high temperature, which is simulated by me rolling that ball of dough into that circle. And as I flatten it out, you can see our simulated metamorphic rock. And you can see a lovely, beautiful marble effect.
Some examples of metamorphic rock would be marble or slate, and you can recognise metamorphic rock because of their often squashed appearance, and they usually have a crystalline structure, but they can also have these beautiful bands.
So there we have it. With just a trip to the beach and a couple of simple experiments, we've explored lots of different types of rock. Very important for the study of something called geology.
Oh yeah.
It's not that light.